You ever wonder how heat moves from one object to another? Well, in this video tutorial, we're going to talk about how heat transfers. The first type of heat transfer is conduction, which is basically taking something hot and touching it to something else. For instance, if I have a hot cup of coffee and I put a spoon in it, that spoon becomes hot because of conduction. I tried this trick to try and trick my mom into thinking that I had a temperature. So I put my thermometer in there, and it turns out that my fever jumped up to about 113 degrees Fahrenheit. Needless to say, my mom didn't believe me. Certain materials are better conductors of heat than others. This has practical applications because some instances we want a good conductor and some instances we don't. The equation for heat transfer rate is H equals K times A delta T over L, where K is the thermal conductivity constant. The higher the K, the better the conductor of heat. A is the area exposed to this temperature gradient. Delta T is the temperature difference of the two sides exposed. And then L is the length of the object. One of the most practical applications of heat transfer rates is your window. The window is the most inefficient part of your house. This is where the most heat flows in or out. But we can limit this amount of heat flow with science. We fill the window with air, which is a very poor conductor of heat. It has a K value of 0.026. The lower the K value, the worse the conductor of heat. For instance, feathers have a similar K value. So the variables here would be A, the surface area of the window, L would be the thickness, and the two temperatures would be the temperatures on both sides of the window. The next way heat is transferred is through convection. In convection, energy is transferred by the bulk movement of high-energy atoms through a fluid. So with our liquid, we have hot red water. That hot water is less dense and it rises up. Now, we have cold water surrounding it, and that cold water is more dense and it rushes in to replace the moving hot air. So you get this cyclical movement of liquid. So I add in my cold water, and there's a spontaneous movement of heat from the red hot water to the outside cold water. Now there isn't a cycle here because the water was so hot, it immediately made my bath all the same temperature. Now if you notice in the video, the lid just popped off of the jar, even though I had tried to screw it onto the jar. This is because of thermal expansion. The metal has almost 3 times the linear expansion coefficient than that of glass. It expanded faster than the glass and therefore popped off. This is why when you can't get a jar open, you run it under hot water. You are expanding the lid so that it slips off of the jar easier. Now, this is not a fundamental law, but it fits pretty well with certain temperatures and certain materials.